The domain of a function, unless otherwise specified, is understood to be the natural domain. And the natural domain is just everything that you're allowed to plug in. So in this case, since we're plugging in t, that's our input, it would be all the values of t for which we can plug it in and we get out a vector. Now, that means we've got to be able to do 3 different things to t, because we've got to be able to get our x function, we've got to be able to get a y value, and we've got to be able to get a z value. So if I just look, in order to be able to get an x value, anytime I'm taking the natural log of something, the argument of the log function has to be positive. So I know from the x function that 3 minus t has to be strictly bigger than 0. That's going to mean that 3 is bigger than t, or equivalently t is less than 3. Okay. T isn't less than 3, I won't get an x value. If I don't have an x value, I don't have a vector in 3 space. Okay. In order to get a y value, I have to be able to take the reciprocal, so I know that t can't be 0. Okay. And then in order to get a z value, I have to be able to take the square root of t plus 2. Now, in order to take a square root, what's under the radical has to be non-negative. Doesn't have to be positive, but it has to be bigger than or equal to 0. So t would have to be bigger than or equal to -2. Okay. So essentially, I've described here the restrictions that I have on t for each of my individual component functions. So the domain for x of t would be all t values less than 3. The domain for y of t is all t values except 0. And the domain for z of t is all t values bigger than or equal to -2. The domain for r is going to be the intersection of those 3 domains. I've got to be able to do all 3 of those things. Okay. So let's just see. I'm just going to plot a number line here. So we've got 3, 0, and -2 are the important numbers. We can't have 0. We've got to be less than 3, so that won't include 3, but will include things to the left of 3. And we've got to be bigger than or equal to -2, so that includes -2 and stuff to the right of -2. So basically, we've got everything between -2 and 3 except for 0. Okay. So I could write this either in set builder notation, set of all t such that -2 less than or equal to t less than 3, and t isn't 0. Okay. Or if I wanted to use interval notation, this would just be the union of 2 intervals. So I could say it's -2 to 0, union 0 to 3, where -2 is the only endpoint that gets a bracket because it's the only endpoint that's included. All right, so nothing too exciting here, but important to understand that the definition of domain is, hey, it's the stuff you're allowed to plug in, extends to vector functions, and that amounts to, you've got to be able to plug it into all 3 of these, so it's going to be the intersection of the domains of your component function.